Dr. Ariane Pessentheiner. Welcome to the podcast.
Hi, welcome.
Okay, so it's been a while since we last spoke. The last time we spoke, we did an interview on Twitch for my science stream there, and you were doing, I think it was a postdoc out in California. Is that right?
Yeah, I've been in California for 3.5 years.
Right, and now you're back in Austria.
Exactly. So I just returned during the Corona pandemic, which was quite interesting. But yeah, I've been here now since end of July, and have
Okay,
yeah, I'm starting
cool.
again, rebuilding and reconnecting to people.
Yeah, it's got to be weird to move during a pandemic.
Yeah, it's coming with its own challenges, I think. But in the end, it wasn't as bad as we thought. Really, everything went really smooth. Um, no big problems or no big things that happened during the travel. But you, of course, had to prepare in a different way, as you would probably normally do.
Yeah,
Yeah.
I bet. I bet. Now you have some fun research that you do. You are specialized in researching fat cells.
Exactly. Yeah. I mean, they can be my best friend and also my biggest nightmare, I think. So depending on how the experiments in the lab go.
And
But
just so that people know, you're not a medical doctor, you're a biochemist, right?
yeah, I'm a biochemist by training, so I'm not treating any people. I cannot give any advice. I can just I can interpret papers and yeah, and say what scientists before me and colleagues are researching and how this makes sense. Yeah.
Okay, so let's dig right into it. First of all, let's start with the very basics. I'm curious to know what exactly are fat cells and what do they do in our body?
Yeah, so I mean, everybody knows this belly fat, or not everybody, but most people have a little bit of belly fat or a little bit of fat where they don't want it, I guess. So you kind of know what fat is. But fat cells are the cells that accumulate or that store this fat that comes from nutrition, from the food that you eat. And they're quite important for the body because they also insulate organs. And um, apart from that, from this being a fat storage, they can also release hormones which regulate the body's metabolism. So, if a fat cell, for example, gets sick, that makes your whole body sick. And as long as the fat cell is healthy, I mean, it's actually also a good thing that it can take up fat because the fat, if it doesn't get stored, it can also make your body sick. So, I mean, fat cells are actually good guys, but yeah, if they are having to store too much of the fat because you eat too much, so your energy consumption exceeds your energy um, uh, exceeds the energy consumption. The energy intake exceeds your energy consumption, then fat cells grow and that leads to a whole bunch of problems. So this is also what I'm going to study.
I have a quick question about that. Can because we frequently hear that people have a slow metabolism. First of all, is there such a thing as a slow metabolism?
Well, I mean, your metabolism is controlled by a lot of different things, and I mean, a slow metabolism, you might be able to say so because also genetic factors control your metabolism, and if your genetics kind of predispose you to having a, I would say, under quotes, a slow metabolism, then yes, this might also be true. But in general, um, I would say it's more like a ratio between your fat content and your muscle content. Muscles are burning energy, and if you have a lot of trained muscles, they burn a lot of energy also. And fat cells are more like the storage cells, as I already said in the beginning. So they kind of slow down your metabolism. They're not made for burning. They're made for storage. And so if your ratio between your fat and your muscle mass is like in the wrong balance, then yeah, you could probably say you have a slow metabolism. But usually that's not the reason for becoming obese, I would say.
Right. And that's one of the things that I like to do on this show is, I had an immunologist on the show the other
Hmm.
day and we talked a lot about popular misconceptions about the immune system, especially right now during a pandemic. I mean, it's kind of crazy the kinds of assumptions that people have about how the immune system works and all that stuff. So
Hmm.
I'm really curious and because you're a researcher and you know fat cells really well. I mean, that's your specialty. You're probably very well acquainted with some of the myths and the misconceptions around fat. And for me, the big thing is, hearing stuff like I have a slow metabolism. Well, I've always been curious to know, well, is that such a thing? And if not, then what is what causes fat cells to become essentially I don't want to say out of control because that's probably incorrect as well, but what causes people to become obese? Is something that is really an easy as saying they're eating too much, or are there genetic factors? Are there viruses that can cause obesity? Like, what would you say are like the top three reasons people gain a lot of weight?
Well, I mean, you've mentioned two of them. Uh, it's if you eat too much, and then also uh, if you don't move enough. I mean, again, you become obese because your energy consumption or your energy intake, the food that you eat, exceeds what your body can burn. And if your body cannot burn the energy, it needs to be stored somewhere. It's like energy gets in, and yeah, either it's burned or it's gonna go somewhere, and it's um basically going into these fat cells. And fat cells are crazy dynamic. They can blow up 4 times their size and store that, and they're mainly built out of fat and little else. I mean, there is a little bit of a cell nucleus and a little bit of other organelles in the cell, but mainly it's fat. Um, what else can make you obese is, of course, also your genetics. So it's usually coming from a family history. If your family suffers from, or a lot of people in your family suffer from obesity, you're probably also more predisposed to develop obesities in some time in your life. So you have to be more careful and look out. Then also the energy content of our food changed in the last decades, I would say. It's a lot more energy dense than it used to be. There's a lot more fat and there's a lot more sugar in it, and also this high fructose, high glucose corn syrup is really, really bad for you. Um, and people don't realize that. I think they don't realize how energy dense their food is and how much more they would have to move to burn this type of energy that they actually consume. And also our lifestyle has changed, so we are much more sedentary than we used to be decades before. Also, our transportation changed. I mean, everything is much easier accessible. You just take your car and you go to the city, and you don't really have to move a lot. You're having a job where you sit on your in front of your computer most of the time. So also that doesn't burn a lot of energy, and all those factors accumulate, and all of them together cause obesity. And that's why it's a very multifactorial disease. So not just one factor causes this disease. It's a lot of factors playing together.
So is obesity considered a disease?
Yes, definitely. It's
Ah.
It's not some. So I think this is probably a misconception that is that I would go against in society. That obesity is just something that people that are too lazy, or people that are not having the life under control develop. It is a disease that is caused by a lot of factors. As a lot of them are preventable, like it's higher energy consumption or also the sedentary lifestyle. But um, I think you could probably the easiest to compare it is addiction to food. And since addiction is also considered a disease, addiction to food should also be considered a disease because it changes also circuits in your brain where you cannot your body needs this type of energy, or it at least tells you that it needs this type of energy. And so this is the part of obesity that can also be treated, or um, that scientists try to find drugs against this kind of addiction.
Is there a solution on the market though for food addiction?
Well, nothing that works so far. It's also a very complicated topic, as you might think. I mean, it's not it's not as easy as it sounds to have like one pill and then you get slim. You have to um, fight this disease from different angles, and most importantly of all is still a lifestyle change. So you have to um, yeah, you have to get rid of this addiction, to get rid of to change the circuits in your brain that sport is a good thing, and that I and moving is giving you also this satisfaction that usually you only get out of food. So yeah, definitely there is no one pill solution for this, and there probably will never be. But it's still something that research is being done on. Yes.
And it's so interesting that, I recognize myself when you're talking about food addiction because my entire family line has, some obesity issues, and my partner and I would joke because I trace my ancestry, to the north of France, which is very heavy on cream and butter, and all of these kind of like larger women who do very well in the winter time, let's say. um, so I guess there is a genetic component then. If you come from a long line of women who were rather large, and whose bodies were adapted for being rather large, you're really going to have to fight harder, right? I mean, you're going to have to like you said, really fight against everything that your body is almost programmed to do.
Yeah, yeah. I mean, have you heard about epigenetics? This
Yes.
is yeah. So I mean, this is the imprinting of your DNA. It's kind of uh, if your DNA is your is a cookbook, then the epigenetics are like post-it notes in this cookbook that give you extra information about the recipes. So, and this is handed from one generation to the next generation. And so, yeah, it could also definitely be that epigenetics is something that it predisposes you to um, just having a little bit more trouble to keep your body weight, because some genes are just like made more than others, or the other way around, and this influences your whole body metabolism. So yeah, you're right. It's often hard to tell which genes exactly, or it's almost impossible to tell. But a family history of obesity definitely gives you a harder start. in
Yeah,
life.
it definitely does, and it's very frustrating when your friends can eat all the sweets and the desserts that they want, and and
Yeah.
you have to be a little bit more careful. Not that you can't. I think that there is an extreme with any topic like this.
Mhm.
There are always extremes, and then the other thing is, people. There's a societal factor, right? I mean, people succumb to marketing and advertising, and like you said, less and or you said that the food is too energy dense. Is that correct?
Yeah, yeah, it's very energy dense, but I'm really glad that you mentioned that because the socio-economic factor. So I mean that's basically the factor that comes from where you live and in which wealth you're living is also affecting obesity development a lot. So I mean, people that are coming from low income countries are usually more prone to develop obesity later in their life because it's just if you think about it, you go into a store and what is the cheap food that you can buy? I mean, I don't know exactly the prices, of course, but uh, a can of Coke costs nothing. But then a can of of juice of real, I mean, it's probably not the right comparison, but let me give you another one. Let's do it with fruits and chips. I mean, you go into the store and you have a bag of chips which costs nothing, and then uh, a bag of apples costs maybe 3 times as much. So what are you going to buy? Um, of course, this doesn't make you full. I mean, the chips and the apples would probably be a better option for snacking, but in the end, you still probably go for the chips, and especially if you have less money, you're not buying this 3 times more expensive bag of apples if you need some extra snacks or something like that. And I'm still not happy with my with my example, but you get the point, I guess.
Yeah, but it also leads me to, I guess, to the next question, which is, if I have two types of food, so let's say a bowl
Mhm.
of oatmeal and
Mhm.
a bowl of chips,
Yeah.
and let's say if we measure the same, it's the same calories. Does it
Mhm.
affect the fat cells the same way?
No, actually, it doesn't. So I mean, it's also the composition of the food. In the bag of chips, you have a lot of fat and a lot of like fat that. So you mean you have the same amount of calories, right?
Yeah, yeah. So let's say you have a bowl of
Same.
chips and a bowl of oatmeal.
Yeah, I mean the same amount of calories should be handled by your body the same way, um, because it's calories is calories. But usually this amount is a lot less in the chips, so it's probably more likely that you eat the same amount of oatmeal and the same amount of chips, and then of course the chips have a lot more calories in the end. Um, yeah, it's that's a good question.
Yeah, I guess it's one of the things that, it's actually something that I see a lot of people asking about, which is like,
Yeah.
well, can I eat like the same calories and does it affect my fat cells the same way? And I don't know if science even has an answer for that.
Yeah, I mean, yes, it does in certain types of food. I mean, for example, fructose or this high fructose, high glucose syrup is somehow making your cells more sick than other nutrients, and people try to understand why this is the case. It probably is because different. It activates the cells in a different way. So yeah, and to understand what it causes in the cells, that's what researchers do in the lab.
Okay.
So you are right, but I cannot give you specific examples about those things right now. So yeah,
Yeah, that's what I
this
was
is
curious about. I was like, is there something, maybe that inside the, like you said, like a specific ingredient, especially manufactured things, I would
Oh yeah, I
assume?
mean there are these trans fatty acids. Did you hear about those?
Of course.
Yeah, I mean they are definitely it's something that is not occurring in natural food in a large amount, but it's occurring in processed food. So this is definitely something that is more toxic to your cells than a normal occurring fatty acid, a normal occurring fat. Um, so yeah, I processed food and high content of also salt and fat and sugar. They're always more um, worse for your body than something like oatmeal that contains a lot of fiber and yeah and the
Interesting.
fiber is also influencing your gut microbiota. That's the bacteria that live in your stomach, or not in your stomach, in your intestine. It influences these differently. So the oatmeal is definitely more
It's better
healthier.
for you.
It's better for you. It's healthier than the chips in any ways. Um, but I'm glad that we kind of depicted those two foods, although I it took a while, but
No,
it's
I
a
mean,
really good question. I like your question a lot.
I'm very curious. Again, it's one of those things that because I come from a family of especially women who are obese, or at least overweight. Let's say, it's always like for myself. I'm always trying to cut through the bullshit essentially, surrounding food and nutrition and fat.
Yeah.
So that's why I ask these questions because I'm like, you're an expert in fat cells, so I might as well.
Well, I'm an expert in fat cells. I'm not a nutritionist, so I mean, I
True.
might still say things that. So my sister, she is a nutritionist, and she might be like, "Ah, come on, why didn't you know that? Or why didn't you say that better than that?" So I don't know about.
Um,
Yeah.
so then why don't you tell us what is exactly your specialty? And I know it's probably going to be very specific and scientific, but if you could maybe say it in a way that, people who aren't scientists can understand exactly what your specialty is.
Well, I mean, what we already discussed, I'm looking into how fat cells develop. So there's a certain program in the cells that need to run for them to become like to get from a normal cell or from a cell that does not contain fat to a fat cell. So this is one of the things that I study. But then also I study the consequences of obesity, which is diabetes, for example. So I just trying to see which factors do influence the development of those diseases, and we do it in the lab that we have those factors that eventually, or that we think that they might have a big influence on these processes, and then we hinder these factors in either genetic ways, or we have drugs that we can use against it. And then we look into, do fat cells still develop, or if it is in an organism, does this organism still develop diabetes? And um, Yeah, so this is basic research in a way. So you try to understand how the basic processes occur, and yeah, this is.
Okay, so I have to ask now, when it comes to diabetes, which is such a major problem in North America,
Hmm.
and I know that it tends to run in the families,
Hmm.
and at least type 1 anyways, because type 2 I don't believe has that many. Wait, so let's go back here. Does type 2 also run in families?
Yes, it does. I mean,
It does.
my grandfathers both had type 2 diabetes, and again, I have a bigger chance to develop type 2 diabetes than a person that has no cases of type 2 diabetes in their family. So I have to be a little bit more careful and how to be a little bit more aware that I don't gain too much weight or that uh, I I stay active. And yeah, I mean it does run in the family uh, as all of these metabolic diseases unfortunately do. Um, but it's only one factor. Again, if I know that, I can stay healthy by just doing the right things, eating healthy food and having enough physical activity. So just because it runs in my family doesn't mean that I need to develop it later in my life.
Which is interesting because in my case, we don't have any history of type 1 or type 2, as
Hmm.
far as I know anyway. And so I always wonder like, oh, do I have to work as hard because it's not in the family? But it can be diabetes is something that can develop
Yes.
because of other factors other than genetic, right?
Yes, exactly. And one of the biggest factor is obesity. So
Ah.
overweight and obesity is like, yeah, it's one of the biggest factor for type 2 diabetes.
Hmm.
And
And what is your so what has your research shown in regards to the relationship between fat cells and diabetes?
well, obesity causes insulin resistance, which means that your body is not responding to the insulin it produces anymore. And insulin is this hormone that is very important that the organs in your body take up glucose from the bloodstream. So if they get resistant, which means they just doesn't don't respond to insulin anymore, they get resistant to it, you develop diabetes. So yes, and insulin resistance starts also in fat tissue, and obesity makes fat tissue sick. So fat tissue cannot take up the glucose it should, and that's how it's causing also diabetes, amongst other problems or amongst other consequences in other organs in the body.
Okay, and so is this what we would consider as yes, a form of inflammation?
Right. I mean, fat cells get inflamed when they are obese, or fat tissue gets inflamed because fat cells can only blow up and take up lipids and fats to a certain degree, and even during this process they already start struggling, and some of them start dying, so immune cells come to get rid of these dying cells, and that again leads to a cycle of bad processes that are running in your fat tissue that influence the development of insulin resistance.
It's so fascinating to me how the body just reacts. It's almost like a ticking time bomb almost, like and have you found through your research like at what point this happens? Is there like a threshold that it has to pass? Do you know what I mean
Do,
by
do you mean threshold to develop insulin resistance and diabetes,
Essentially,
or?
the way I'm understanding it based on how you've explained it is that
Hmm.
the cell becomes inflamed, the cell
Hmm.
then dies, the immune system comes and fetches it, and then somehow that involves the pancreas.
Yeah, I mean the pancreas. So um, it's like a communication between organs in your body all of the time. So it's not just the fat tissue and the pancreas, it's also the brain and the liver, or the muscles that are all kind of in communication with each other. So if you have an imbalance in this metabolism in one organ, it also influences other organs. So it's kind of a domino effect. Um,
Okay.
and and often it's it's also difficult to say where it comes from, but it's an interplay between all those organs. And yeah, if one of them is not working fine anymore, the other ones have to work even harder, and that makes them again sick. And it's a bad circle that
Yeah,
occurs.
it is. One of the things we talked about briefly again when I had a podcast with with Dr. Brian Haidt, who's an
Hmm.
immunologist, is inflammation. I couldn't believe like the effects of inflammation. I think are even understated in media, in school. Uh,
Hmm.
I would imagine that for you, inflammation is a very serious red flag.
Yeah, definitely. I mean, inflammation is not only a problem in obesity, but it's also a problem. You've heard of heart disease or cardiovascular disease, right?
Yes.
So that's inflammation in your arteries. And they're sometimes caused by obesity or even often caused by obesity. So, inflammation in your body, and especially chronic inflammation, which means that the inflammation is not resolved, so it doesn't go away, that's a bad thing. So, that means that you don't feel anything bad. You don't feel worse than I mean, if you're really sick and you have a really full blown inflammation in your body, you feel bad. You're sick. You probably have fever, but this low chronic inflammation you can't feel, but it's there. So that means your immune system is always alert. It's always on an activated state. It's always like looking for some threat. And unfortunately, this alertness also leads to destruction of sometimes healthy tissue, and and also to have some type of yeah of negative consequences on a lot of different angles. So it's just your immune system is kind of crazy all the time.
It is, and it's just interesting because it impacts, obesity as well.
Hmm.
Stressors like lack of sleep,
Oh yeah,
not enough sleep, and all of a sudden you're gaining weight.
yeah. I mean, this is also one of the factors that is probably underestimated. Shift work is a big factor in all these diseases, also heart disease and obesity. Is often seen in in people that are uh, doing shift work, because the body's metabolism is also directed by a rhythm, and this rhythm is called circadian rhythm, which basically means that it has this type of 24-hour cycle, which is guided by outside light. It's guided by the sun. And the very fascinating thing to me, I mean, I'm a little bit fascinated by the circadian rhythm, is that every single cell in our body has an inside clock, which kind of runs in this 24-hour circle. And for shift workers, this clock is often disrupted. And that shifts your metabolism in, I would say, uh, from a storage phase to a consumption phase and a storage phase again, in a way where it shouldn't be. I mean, it should be in a stage where it burns the fat, but it's actually in people have to work during a phase. Yeah, it's just it's just confusing, the whole clockwork in your cells and the whole clockwork in your body, and that's often the reason also for uh, a development of a metabolic disease.
You metabolic disease. What? So what do those include? I know that it includes, I guess, diabetes is a metabolic disease. What other
Hmm.
metabolic diseases are, influenced or that influence fat cells?
Yeah, heart disease is one of it. Also, there is a metabolic kidney disease. So it's often uh, caused by obesity. It's often caused also by diabetes. But sometimes also, if the kidneys get sick, they can also influence other types of diseases. And then metabolic diseases, of course, also obesity. Yeah. So everything
Okay.
that influences your body's metabolism. Yeah.
And really quickly, last question about fat, and then we'll get to other topics. Is what is the difference between fat burning and fat storage? Is are there cells that do the burning?
Yeah, there are specialized fat cells that are called brown fat cells, and they do some burning. They are mainly found in babies uh, because babies have to keep their body temperature, and they have a lot surface for their body size. So they lose also a lot of heat. And so the body has generated this cool system where they can actually generate their own heat to a certain degree. And these are these brown fat cells. So for a long time in research, they have been thought as the holy grail in obesity control, because if we could activate normal cells, normal fat cells to become brown fat cells and they start burning fat instead of storing it, that would be, of course, ideal to fight these diseases. But the reality doesn't look as easy as it might sound. So you cannot just activate fat cells in your body to become brown fat cells. Although in experiments, this of course has been done. And the other thing is that in human adults, we don't have a lot of those brown fat cells. We do have them, but they kind of get lost after your baby. Uh, so yeah, but they're pretty cool, to be honest. I really like to look at them also under the microscope. They look very cute. And and they are fascinating cells because they're really specialized in this heat producing versus storage function.
So is it incorrect then when you see something like an advertisement that says burn fat or, burn this, burn that. It's all a bunch of crap, right?
Yeah, I mean, I would say yes. In most cases, it is. I mean, you can, of course, increase your metabolism. What we talked about in the beginning, you that your body just consumes more energy in certain ways. But I think the best ways to do so is still physical energy, physical activity, and also a healthy diet where you just don't have as much that much energy in the healthy diet. You have fibers, you have um, fresh ingredients, all those things. Uh, I would not trust any of those advertisements if I wouldn't see the science behind it. I mean, let's say frankly, if it is really proven that it works, I mean, why not try? But most of those things are just fake.
Right.
Yeah. Yeah.
It's just it's snake oil marketing.
Yeah,
I
exactly.
So I have to ask you, one of the things I've learned from a lot of friends who have done their PhDs, whether it's in science or history or whatever, is that they've always had some sort of personal connection with the topic that they've specialized in. Otherwise, it wouldn't keep your interest for very long, I don't think.
Mhm.
What is your personal connection to this research?
Well, I think my personal connection are maybe really my grandparents, because they suffered from diabetes I mean, most of my adult life, and I've seen how that affects them, how that affects their daily routine, because they had to measure insulin levels, and then they had to inject themselves with insulin. So they were all like really dependent on this things, and I'm sure that it made their life harder. Um, so that's definitely one personal connection that I have, and I am just naturally curious. I mean, I like to things. I like to know how things in our body work, and um, Graz, the city where I did my university studies, it's very specialized on all this obesity research and fat cell research, and also how fat cells work, what they do, what are the different factors that influence it. So it came naturally that I started with fat cells, and then I got very interested in understanding how they work further, because it's really fascinating, and it's such a important topic to work on, because it's just affecting so many people in the world. I've read a fact that since 1975, the cases in obesity tripled, uh, and this it's just killing so many people every year that yeah, I just think it's really important topic for
It
me.
is. It's exceptionally important, and for me, what I find even, as a as the podcaster, as a person who's asking the questions is because I see the other side of things, which is all the myths and the misconceptions, and
Yeah,
that gets so much more playtime than the actual science sometimes, like so I think it's so wonderful that you're studying this topic, that you're doing it, like you said, for because you had a personal connection, but also out of curiosity, which is what I think will make it so that it lasts even longer, right? You have to have the curiosity as a student and as a scientist. Is this something that it's something that will allow you to just keep going? Do you do you enjoy being? I guess I know the answer to this, but I would assume that you enjoy being a scientist.
oh yeah, I definitely do. I mean, I like this figuring out stuff, and you never know where it leads you. I mean, you follow up a lead, and of course it it could mean that that you figure something out, but often you get new questions rather than answers. And I mean, it has some. It's kind of cool to also have this first question, and then you realize, oh, but there's all these other questions now that need to be answered too. I mean, it's cool and it's daunting, and it's also often very depressing, to be honest. But but yeah, it's this vast majority, it's this vast amount of knowledge that we can never really figure out completely. So there will
Yeah.
always be an open question in the end, and something that we can still follow up. There will never be all the answers to everything, and I think that makes science really cool in a way. At least for me, it does, because it's there's still something new to figure out
Yeah, it's
every time.
and the patience. The patience, the long-term thinking, I think, is what makes a scientist different from somebody who perhaps isn't suited to become a scientist is the ability to just be patient.
Yeah, I mean, this is definitely something that every scientist needs for in and then also not only being patient, but only also being um, a little bit tolerant to uh, yeah, to bad things that happen, to frustration. So if you're not frustration tolerant, it's probably also not the right job for you. And this is
True.
probably also something where I'm sometimes, I have to say, I'm struggling with this frustration part of science. The curious things, that's what gets me, but then there's often a long stretch of this having to be very very patient to get to the next point, and yeah, this can be hard. Yeah.
We spoke, well, essentially, we brought up the topic of imposter syndrome
Hmm.
at some point, you and I, and because you also, for me, I try to bring it up as often as I can because for two reasons. I find that there's a link between the science and the arts, and in the
Hmm.
arts, imposter syndrome is so normal. It's so common. And then I learned recently though that it's also very common in academia.
Oh yeah, it is. It's really really, I mean, it's very common, and I've heard something in on Twitter. uh I saw that a couple of weeks ago, and that kind of stuck in my mind. It's like the more you know, the less, the more you know, the more you realize how little you know.
Mm.
And I think that's probably why imposter syndrome even grows the farther you get in your career. Um, at least I can tell from people that are in the same stage of career like I am, that imposter syndrome is definitely a thing, because you think that you should know things already because of your like year long experience and all the reading that you're doing, and then you don't know it because people are not made to remember everything, or simply probably you haven't read about it. So there is no such thing as you have to know everything, but often scientists think that they are supposed to know everything, at least what when it comes to their field. And so imposter syndrome is definitely something that destroys a lot of uh, good scientists also, if it is overboarding, um, because they're never satisfied with what they're doing and what they accomplished, and they always think that there's someone out there that knows it better than them, which is probably true, but I think even this person that knows that better thinks the same again. So yeah, I
Hmm.
mean, we always think that we are not suited to do the thing that we actually doing. So,
Yeah, it's such a phenomenon that I think, and I think it's under discussed. I think,
yeah,
I think everybody knows it, but nobody wants to talk about it because nobody wants to admit to feeling it,
yeah,
as though it's somehow going to decrease their value if they admit that they feel like a charlatan, you know?
yeah.
Uh,
It's really yeah, it's very interesting because in the beginning of your studies, you think, "Oh my God, all those people, they know so much," and then you're at this stage, and you think, "Oh my God, all these other people, they know so much, and I don't." So, it never really ends. It's kind of crazy, but I guess we should all be more proud about ourselves, and
I think
that's
so. I think so. And another thing I wanted to bring up because it's something that I see a lot on your Twitter account is that you do art.
yeah, yeah. I mean, I've always
Yeah.
done art. I think that's. I have to thank my mom for that. She was an art teacher, or she's an hand she, a crafting teacher, let's say like this. And so she always let us do all those things at home. We were crafting all the time, or painting, or doing other stuff, and so she fostered that very early. And then I also had, or I actually have, my best friend who is she's just so creative, and so she became my best friend, and so I was in this position where I was, I had to do something. She was painting all the time, so I painted too. kind of keep up with her. I was never that good, but I just realized that creativity is a really, really important part of my life, and that's why I also try to incorporate it now more into my career. Um, and so yeah, I'm doing a little bit of science art, I would say, or I started with it. But what I also really want to do is communicate science through art. And communicate science in general, because this is where I can put both my parts together, this creative part and the curious part, and I can merge that, and I think that's a good fit for me.
It's so beautiful. There is, I think, really, and this goes back to the beginning of our talk, which is there's a connection between the curiosity in science and the curiosity in the arts.
Oh,
And
definitely.
yeah, do you feel the same way when you're exploring something scientifically as when you're painting?
Yeah, I even sometimes have that more if I'm painting or crafting. So I've already tried a lot of techniques and a lot of different things in crafting. And every time I see, if I approach a project, my brain starts already going wild of how could I accomplish that? Which materials do I need? How do I put them together to kind of get this result? And there is a lot of same thinking in science as well, although it's not as easy to put into um, probably words or into action as it is in crafting, because you yeah, in the end, in crafting, what I like is you have a product, and in science it's often a little bit more difficult to show because your product is often just numbers on a page. And but the thinking process is often similar. You have this problem and then you try to find the things that you need to approach this problem. And I really do think that scientists can learn a lot of from artists in this creative process thinking. And the other way around, I think also artists can learn a lot from scientists. So I really do think that this liaison between scientists and artists can be very fruitful. Um, I've done this workshop together with a performing art department in science communication, and I was just fascinated how performing artists approach communication and how to communicate science in a way that is very different from how scientists sometimes do. But uh, but yeah, it also made me realize how we can learn from each other in this way.
Yeah, I think so. I really do. I really think that there's a bigger link to explore between scientists and
Oh
artists.
yeah.
I really, really do. So I'm thrilled that you're doing this kind of work. What's your long term objective? What is the thing that you want to be doing 5 to 10 years from now?
Yeah, I mean, if you would have asked that 5 years ago, and would anybody have said that we are in the middle of a pandemic? I don't think so. um, but yeah, I mean, I think 5 years ago everybody lied, but I try not to lie right now. What I try to do long term is really teach other scientists how to communicate their science better. That's I think this is the project of my heart now, where I want to get to, and I'm taking the first steps by promoting myself, promoting my science, promoting my communication skills a little bit more. But yeah, in the end, I want to be the one that is behind the scientists and helping them to become better communicators. Um, and this is just, yeah, again, I think it's the perfect merge between my creative and my scientific side. So I'm not losing this uh, things that I learned during my studies, This I will still be a scientist, but yeah, I can also be a teacher or a coach for other scientists to improve their skills. So that's
Yeah,
where I do want to develop to. Uh, I'm not so much interested anymore in staying at university and having my own research group, but uh, yeah, this new project is what my heart is burning for.
I think it's wonderful because in a way you've already contributed to the research. So it almost you must feel at a certain point like, okay, I've done this.
Yeah, I mean, there is still more to come, I'm sure.
Hmm.
But also there's this new way, and it's kind of exciting to
Yeah.
reorient. Um, and I can just encourage people to make decisions to uh, yeah, what they want to do with their life. It took me quite a long time to realize that I, I'm I'm a scientist much longer than I'm a science communicator, and so it I think part of it is also this imposter syndrome thingy that we talked about before, that you never feel like you're able to do something like that, but then once you're doing it, you realize, oh, it's actually working quite fine, and yeah, it's good to just jump and see what happens.
Well,
So
I'm
that's what I'm
super
doing now.
excited. I'm definitely excited for you. I think you're doing the right thing. If your heart's into it, go for it. And it's a growing field. Science communication is a big, big deal right now, and it's much, much needed to fight, the kinds of myths and misconceptions that we talked about earlier. So,
Yeah, right.
yeah, definitely. Listen, it's been such a pleasure having you on the show. It's been amazing to be able to kind of poke at you and ask you questions, even though some of them perhaps were kind of, really complex and curious. But that's the way it goes sometimes.
Oh, that's
So
fine.
yeah, I really appreciate it. Thank you so much for coming on the show.
Thank you for having me.
It's been fun.
Yeah, it was a lot of fun. Thanks.
Thank you.